Okay, this is the fourth video for those people doing a maze-based shooter. Okay, and this one's going to detail collision detection with the maze and movement of a player in that maze so that they don't walk through the walls. Okay, so you need to make sure that you've done video, well, 1, 3, 2 is optional, remember, before you start. Okay, so we're going to start with the helper routines, the helper methods, and the helper fields that we need in the level class. So if you go to your level class first, okay, and at the top, after the class definition line, just put a couple of blank lines, and we need to create a list of integers. So we do list int. We're going to call this walls, and this is going to define what tiles are wall tiles. Okay, so we just say walls equals new list int bracket, well, parentheses, and then a semicolon. So we'll populate that in a second. Okay, right, so if we scroll down to the constructor, which is just below, this is the constructor for level. We've got this level viewer thing. We're not going to want that because we're going to have a sprite in a minute that we'll be able to move around the maze, so we can make that scroll the maze for us. So we're just going to comment that line out. So select comment at the top. Right, and then we're going to create a method and we'll call it set collision data. And this is going to set up the tiles that are walls so we can test for those later on. Okay, so that doesn't exist, so we're going to do control full stop and select generate method and it's created just below. So a very simple thing to do, we just need to add the tile characters that are wall definitions to this wall list. So we say walls.add, and then we open a parentheses and we say tile index of, and then we need to put in single quotes the characters. So for our tile map, if we just quickly look at the tile map, level data, level 1. For my demo one, and yours might be different to this, I've got XM, you can see there, I put it in my little comments, X, M, and W are walls. Okay, so that's what I want to add to my level. So let's go back to level.cs and just put X and then finish off with a semicolon. Now what I'm going to do, I've only got to change the character, so I'm going to copy using Control C and then paste 3 times and just edit the character part. So I'm going to put an M in there and a double U in there. So that's just defining 3 tile types as wall tiles. Okay, and we'll use that in a minute when we create the helper routines. We've just got two small helper routines to write. Okay, so let's just below this method, so we're looking for that closing brace. Just going to press a couple of enters so we can get some blank lines, and we're going to create 2 methods. So these are going to be called hitwall, and they're just going to check to see if the position that we give it, so a vector to an XY position, to see if that position's inside a wall tile, and we'll say true or false. So we do that by saying public because we want other classes to access this, bool because we want to return true or false, and then we put the name hitwall because that's what we want to call it, and then we're going to give it a parameter, and it's going to be a vector2 value, and we'll call it position. Okay, so if you press enter and then put a left brace, it should type a right brace, press enter again, and it'll put our cursor in a position to start writing the code. I'll keep scrolling up so you can see. Right, so all we've got to do is pick up what tile's at that location. So we're going to say int tile equals, and then we're going to ask the engine to get the graphic tile at the location given by that position. So we're going to say position.x, position.y. Now watch out for the number of brackets. You'll see that you've got 2 closing parentheses, which closes that one and that one. Okay, and then we end the line with a semicolon. Right, so all we're going to do is we're going to say, right, if that, whatever tile we've now got in the variable called tile, if that is in our wall list, then that will be true and we'll return that value. So all we've got to actually do is say return walls. So we're looking at the list walls and we say, does it contain our tile? So that's either going to be true or false. So if it is a wall, this return statement will return true. If it isn't in that wall list, it'll return false. So obviously if it is a wall, that's when we've detected collision effectively. Right, okay, so that's one of the helper routines. The other one, when we do movement of our sprite, we could just check the center of the sprite, and that is the simplest way of doing it, and say, where is the center? If I've moved left, where is the center in a wall? If it is, don't let the player move left. But we want to do it a little bit more sophisticated than that. So what we're going to do is we're going to have a series of offsets. Okay, and we're going to check multiple positions around the sprite. Now you can have as many of these as you want based on what your sprite looks like, but we'll treat it as a square block in this case, and that's usually good enough, okay, to give the illusion that we're bumping into the walls. All right. Perfect is the enemy of good enough when we're programming. Okay, you can polish and polish and polish, but if you don't need that polish or you won't see any benefit of that polish, there is no point. Okay, so what we're going to do is we're going to create another little helper routine that's going to take these offset positions from the sprite, and it's going to check to see if all of those offset positions have hit a wall. Okay, so this is a little bit more complicated, but it's going to do the same job, so we're going to give it the same name. This is called overloading. So we're going to say public bool hit wall. This time we're going to give it a vector2, which is going to be our center position. So the center of the sprite will give it. And then we're going to give it a list of offsets, a list of XY positions offset from the center. So these are going to be vector2s again. So we can say list vector2. So that goes in angle brackets, and we'll just call it offsets. Okay, move to the end, press enter, press the left brace key, press enter again, and we're ready to tap our code. And there isn't really that much code to do here. So all we need to do, we've got a list. We're going to go through each item in the list, so we can use a for each loop. So if you highlight using the IntelliSense for each and do tab, it'll build the loop for you. Okay, so this first thing we need to say what type it is. So it's going to be a vector2 because that's what our list has got. We'll give it a name. So instead of item, we'll call it, or I don't know, position. And instead of collection, we need to put the word offsets because that's what we call the parameter up here. So we called it offsets. So we're basically saying for each vector2 in that offset list, let's do a loop. Let's go around and have a look. So all we're going to do is we're going to use this hit wall routine that we've just written. So we're going to say if hit wall, and you'll see it's got like one of two there because we've got two things named the same thing, but they've got different parameters. If you just click that little arrow, you'll see it lists the different ones. And now the game engine's littered with overloaded methods. Okay, so this is actually quite good evidence to show that you've used the features of object-oriented programming. Okay, we could have called it a different name, but it's nicer to call it the same name because it does the same job. Okay, so we're going to just say we want center plus position. So we're saying whatever the center position is plus the offset, check that position to see if it's within a wall. Okay, if that is true, so if that statement is true, we're going to say return true. Okay, if it isn't, we'll go around the loop and check the next offset. If we go through every single offset and find that none of them are in the wall, then we're going to return false to say, oh, you're not hitting anything. That move's going to be valid. Okay, so that's it. That's all we need to do to the level class. So we've just added this list to say what tiles are walls. We created a little method to set that list of walls. So we had X, M, and W in my example. Yours may be different. And then we just created a little routine that says, is a position inside a wall? And then we created another routine that said, right, well, given a list of positions, can you check all of them to see if they're in a wall? And you'll see we'll use that in a minute in the player character. Okay, so the only other thing I need to do is generate the player. Now, if you've already generated your player, you can just watch what I'm doing briefly. But I added my generate sprites routine. I had this new player thing. I've got it commented out because I didn't actually build it in my video. So I'm going to uncomment that. It'll moan because I haven't got that, and we're going to create this sprite. Okay, so like I say, if you've already created a sprite, you can just watch me doing this and just chill out. If you haven't created a sprite, then follow along. All right, so I'm going to create this sprite and I'm going to give it its starting X position, the bottom that I want for the sprite, and what I'll do is I'll align the bottom to it. Maybe not as important with a maze sprite, so you could change this and do it like we did the coin, where you just give it a center position. That's up to you. You can play about with that, however that best fits for your game. And then we pass another parameter. So we've got 3 parameters here. So we've got an X and a Y position, and then we've got this, which means we're going to give the player a reference to the level, because that's what class we're in. And what that'll allow the player to do is to ask about the collision detection. So it'll be ask the level, and it'll be able to run the hit wall routines, the methods. Okay, so we're going to put our cursor over this where we got our error, and we're going to do control full stop, and we're going to say, and be careful which one you pick. You want the new file one. So we want a separate file for this player class. So let's just generate that. Should come up in the tabs at the top. There you go. Right. It won't have any of the import statements at all. So what we need to do, if we just go to the top of level and take all the using statements, copy those, put them in player. Make sure this is right at the top because they have to come first. The ones that we're not using are grayed out. If when we've finished, we can easily go back and just take these out. But actually, the compiler just ignores them if they're not being requested. Okay, but that just makes sure we got things, we don't have any complications later on. Right, okay, so the Visual Studio will have guessed what we wanted for the player. Okay, it's took the parameters. Okay, it's given them guessy names, so it's guessed what the names might be. It's actually guessed quite well. And then what it's done, it's created fields from all. But the only one we want to keep as a reference is level. So we will delete the bottom one and we'll delete the X field. We need the level one because we need to know what level we're in so we can interact with it. These settings, we've got this.x equals X. Well, that's now moaning because we haven't got that, but we are actually going to use those, but I'm going to do those in a second. So I'm going to delete that line and I'm going to delete the bottom line. I just want the level setting. The other thing I need to do, I want this class to be a sprite. So I'm going to go back up to the class line. I'm going to say inherits, which is what the colon means, and then I'm going to put sprite. Okay, so I'm taking on all the features of a sprite, all its fields, all its methods, all its other things that it's got, all its members as we call them, and I'm going to add my extra stuff to it. Okay, that's all the inherit thing means, remember. Right, the next thing I need to do, because it's a sprite, if I want it to be managed by the game engine, I need to add it. So I'll say gm.enginemanager.add sprite, pick the right add routine because different types of objects. And we just put this. And again, remember, this just means it references this particular sprite, this particular version of the player. Okay, then we're going to define some frames. Now, I've clicked Team Explorer by accident. The only sprite I've got that's suitable on my sprite sheet is my Mario sprite, which I used on the platform version of this game. I never actually got round to making like some thing that was sensible in a maze, so I'm just going to use the Mario sprite. It doesn't matter. Ideally, really, if you're doing these sort of games, you want a top-down sprite because it reduces the amount of animation you've got to do. But I'm going to use that Mario sprite anyway. Now, I know where my rectangles are for my frame, so I'm just going to throw this in quick. So I'm going to say frame.define. So it's gmtx sprite, new rectangle. I'm not doing this out of my head because I'm useless at that sort of thing. So I can say 136, 153. If you've got your own sprite, you use your rectangle definitions. Right, I'm going to have 3 frames because I'm going to show you how to do animation. So I just copy that line and change the numbers. So I've got 43, and I sensibly lined them all up on the same row height, 93. Okay, so that defines my 3 frames. Now then, what I'm then going to do is I'm going to set animation up. And what I want for this one, I want it to animate when I walk or move along. So I'm going to use a distance animation technique. So I count how many pixels I've moved, and I can make that a fraction if I wanted to. And then every time I've gone a certain amount of pixels, I'll change the frame that's displayed. So if you work this out well, if you've got a graphic with a defined step distance, you can work out how many pixels each step should be between each frame, and you can sort of like, I tend to guess generally, but I'll set this up and show you how to do it. So we say frame.animator dot, and I can never remember what this is called because I named it so badly. I know it's a distance one, so I'll just type distance and see what comes up. It's the method animate distance that I want. Use the picker all the time. So I'm going to say, right, every 5 pixels, do the animation. Now, it'll ask me, once I put my comma in, what I want to do when I get to the last frame. So what I want to do, I'm going to reverse the animation. So I'm just going to go backwards and forwards through this sequence because it's a really, really simple animation sequence. You might have an animation sequence that loops, so you want to say repeat, and you can see there's various different things. There's some really good ones like that are built like kill, which allows you to do like explosion effects. So when you get to the last frame, the sprite disappears. That's quite handy. There are some more complicated things. You can see those. You can stop an animation at the end. You can stop and then flick to the first frame. But we're just going to do reverse in this case. You can see again this is overloaded this one, so there is another method that we can use, and if we carry on and put a comma, you'll see what the other parameters are. And now it's asking me for a start frame, so I'm going to put 0, and the last frame I'm going to put 2, and I'll explain why in a sec. Okay, so when we define a list, the first item in the list is at position 0, which is why I've said the first frame is 0. The next one is at position 2, so this is sprite frame 1. And then I said 2, didn't I? I meant 1. And then the last one, the third frame, is at position 2. So I'm saying animate between frames 0, 2, 2. So it'll go 0, 1, 2, and then it'll go 1, 0. Then it'll go 0. Then it'll go 1, 2. So it'll keep flicking backwards and forwards. Experiment with what works best for you. Okay, right. Let's sit the sprite where we want it. So if we say x, capital X equals little x, so that's the x position of the sprite, and we say the y position is equal to bottom. Okay, right. I'm going to leave the alignment as center aligned. It's up to you. You can just say align equals and then align dot and then pick your alignment mode. So I'm going to formally state it as center, but that is the default, to be fair. Right. The other thing I need to do is I need to set up my control code. So I'm going to create an update callback. So I'm going to say update callback plus equals, whoops, move. I'm also going to broadcast the position of the sprite for the scrolling manager. So I'm going to say update callback plus equals broadcast. Now the order I put these is the order that these are run. So I need to do the broadcasting last. If you have some more callbacks, you might have for various other actions, if you're going to broadcast a position, do it after you've done all the movement code. Okay. Right, one other thing I'm going to do, I'm going to set some offsets for my collision detection. So when I'm moving left, I want to check particular positions to see if I'm in walls. When I'm moving right, up and down, I want to check different positions. Now I'm going to do this by creating 4 fields at the top. So back up to where the level reference was saved in class, I'm going to create a list of vector 2, and I'm going to call this one left off, and I say equals new vector 2. You see I'm using the picker, it's picking the right things. Right, I want 1 for left, right, up and down. So I'm going to copy paste this. So I'm going to say copy, and then I'm going to go paste, paste, paste. So I've got 4. And then I'm just going to change the names of the others. It's moaning now because I've got things named the same thing and you can't do that. So I'm going to have a right off which you'll probably do with your first car. We're going to have up off and down off. Okay, they're the only offs we need. Right, let's get rid of a few of those blank spaces. We're going to populate those in the same way that we actually populated the wall list in the level just a few minutes ago. Okay, so we'll do that by creating a method. So let's just scroll down to our constructor for our player sprite, and let's just call it set offsets. It shouldn't exist. So we've got three things that don't exist yet. So we're going to build each one of these. So let's do the set offset. So let's do control dot or control full stop and press enter, and it'll create the offset thing. Right, so let's create this routine first. Now, we're going to use half the width of the sprite, okay, to define where these offsets are. So we're going to create a couple of helper variables here, one called wdiv2, which is going to be the width divided by 2, and we're going to do another one for the height, and we'll call it hdiv2, and that's going to be the height div2. Okay, if you're going to change the size of your sprite, make sure you do it before you set up these offsets, otherwise you'll get some very odd collision detection going on. In fact, really odd collision detection. Okay, right, so we're just going to define an add. So let's just do the left one first. So we're going to say left off dot add, and these are vector2 values. So I'm going to say new vector2. Okay, so this is an offset from the center. So when we're moving left, we want to be checking the left-hand edge of the sprite. Okay, so that is half the width, but left directions are negative directions. So we're going to say minus wdiv2. The height of it, now what I'm going to check the top corner and the bottom corner of the sprite. So let me just go back to my graphic and zoom in on Mario. Oops. If I'd have selected him, it'd have zoomed in there. Right, so when Mario's moving left, I want to check this edge. Okay, so that's the bottom left edge, and I want to check the top edge, bottom top left edge. So that's half the width away from the center, and up is negative as well, so that'll be minus half the height, and down will be plus half the height. Okay, so let's just do that, and you can see that in action. So we're going to say hdiv2, but we don't want to be right on the corner, because if we do that, we'll get stuck when we're trying to move up and down. Okay, so we're just going to take a little value off. So we're going to say -1. Okay, right, so that's the bottom left-hand corner. So let's just copy and paste that, and let's do the top left-hand corner. Now the only difference is, so the side, the x value is the same, but we need to go up. So we're going to say negative, and we don't want to be right at the top, so we're going to add 1 to that. Okay. Now we're going to do the right-hand side. Now I was going to be lazy and just copy paste, but you shouldn't really copy paste. So I'm going to say right off dot add, and it's going to be new vector2. This time it's going to be positive width. So wdiv2, but the h values are going to be the same. So let's do the bottom corner first. That's -1. And if we do right off dot add new vector2 wdiv, oops, press the right key, it might help, wdiv2, and it's going to be minus hdiv. So it's identical to what we did for the left-hand one, +1. So that's done our left and right. Now we just got to do the top and bottom. Bit tedious, but it's a setup. Sometimes setting up data is tedious. We could have probably written an algorithm to do it, but it's quicker to actually just type the ready numbers in ourselves. So we're going to do the up off. So this time we want to check, let's have a look back at our Mario. So when we're going up, we want to check this corner and this corner, and when we're going down, this corner and this corner. So let's do that. So we're going to say add new vector2 keep using the picker, it'll save you bags of time. So let's do the top left corner. So that's going to be minus wdiv 2. We don't want to check right in the corner, so we're going to put +1. And then up is minus hdiv 2. Okay, so I'm going to copy paste that and do the right hand corner, which is just changing the minus wdiv to a positive and subtracting 1 so we don't go right into the corner. Right, we've just got to do the down off, and then we can start putting our controller code in and we'll be able to test it in a minute. So down off to add new vector 2. So again, we're going to do minus wdiv 2 +1, and because we're going down, it's going to be positive for the hdiv. So hdiv 2, I'm going to copy and paste that. One thing, I don't know whether I've said it in the video, if you've just got your cursor on a line and you do Control C, it copies the whole line. If you then do Control V, it pastes the whole line, so it doesn't like paste it in the middle. So Control V, bang, saves it just like that. It's really quite nice for us. Okay, so we just got to change the wdiv to positive and say -1. Okay, so there's a clear pattern there. Right, okay, that's the offset setup. So the only other two bits we've got to do is now create the broadcast and the move. I'm going to just create the broadcast because that's trivial. So I'm going to say control full stop over broadcast. It says generate method property field. We want the method one. So let's generate a method. Okay, here it is. It's created the method. So we just want to broadcast a message. So we can say message bus dot instance dot broadcast message, and it's going to be extra message types dot, and it was view position, and we're just going to send the center of this sprite. So we say center 2D. Okay, so that's nice and easy. We've already done that with the little level viewer. Right, let's create this move routine. So move over move, do control full stop, say generate method player.move, and it does. And we're just going to write this code. So what we're going to do is we're going to check, and I'm just going to use the cursor keys. What we'll do is if you press the left key, we'll check to make sure that the position to the left isn't a wall. If it isn't, we'll move. What I'm also going to show you is how to flip a sprite. We're also going to keep track of the direction that we've moved. Now we'll want that if we're shooting, and we want to shoot in the direction we're moving. Okay, so we're going to create a field. Okay, so that if we're not moving and we press the shoot button, it shoots in the last direction we moved as well. All right, so we're going to keep track of the direction we moved. So the first thing we could do is we're going to say move direction, which doesn't exist, but we're just going to run with it. Move direction equals vector 2.0, i.e. no movement. No, we're not going to do that actually. We are going to create a field. We're going to do it properly. We're going to say vector 2. So I'm just going to the top of the sprite, vector 2, move direction. I've got crumbs all over my laptop. Just scratching off. So I'm not pausing because I'm thinking. I'm pausing because I've got crumbs all over my hand. Right, so move direction equals vector 2.0. Okay, so I'm just initializing that value so that we're not moving. Right, okay, scroll back down to the move subroutine. Right, so what we can do is it's going to be the same structure and we're going to do it 4 times. So we're going to say if gm.inputManager.key, and we'll use, there's a couple of ways you can do this. We'll use key down. So it just checks to see if there's a key held down at any point in its life. So we're going to say in the brackets keys dot left. So if that's true, and not, which is what exclamation mark is, level, so this is our reference to a level we're in, hitwall, the routine we wrote, and we're going to pass to it, so I've opened a parentheses there, the center of our sprite, center 2D, comma, left off. Okay, put the other parentheses in for us. If that is true, so press enter at the end, opening brace, So left brace, press enter so that we can put our code in. If that is true, we are gonna alter our move direction. So we're going to say move direction dot x. Oh, am I going to do it this way? Am I going to do it this way? He says. I do not know whether to do it this way or not. I might actually, just for now, we can update this later. I'm going to set move direction to 0 at the start. Okay. Yeah, I am going to do. Am I going to do that? And now I'm thinking I've got crumbs this time as an excuse. Beep, 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 beep. Yeah, I think I am going to do that. Okay. When I do bullets and things later on, we'll use something about this to say it. Right. So I'm going to say minus equals. So I'm now got back to actually writing my code. Right. So I could. What I need to do is I need to set a speed. Okay. So I could type 300 pixels per second, and I could write this gm.eventmanager.delta. And what that does is it works out for the current frame that's being worked on, processed, it turns that 300 into a value that represents 300 pixels per second. But this is bad. I've put what we call a literal constant down. So if I want to change the speed, I'll have to change it here. But I'm going to do this 4 times, and I'm going to use the 300 4 times. So what's better is to have either a constant, or in this case, what we might have is a variable. And the variable is preferable because in the future, what we might want to do is have a pickup that changes our speed, if it slows us down or speeds us up. So I'm going to say speed. Doesn't exist. Okay. So what I'm going to do is I'm going to see if the auto fixer can solve this. I'm going to say control full stop, and it says generate field and speed. That looks good. So I'm going to try that one. And in the little pop-up, it's put float, which is the type I wanted. So it's going to be a fraction value. So I'm going to say generate field speed in player. And it should have created it at the top. Okay, so let's scroll up to the top. Well, let's not scroll up to the top. Let's do it a different way. If we put our cursor over speed and press F12, it'll go straight to that code for me. Right, I'm going to default this value to 200. And you'll have to play with that depending on what speed you want your character to move at. So that's 200 pixels per second. So if your screen is 1200 wide, it will take 6 seconds to get from one side of the screen to the other. That's how you can work out what your speed ratio should be. Okay. Right, I want to go back to the code I had. Quick way of doing that is to do Control minus. Takes me back. You can scroll down if you're sado and you want to scroll, but I'd prefer to use quick keys like that. Right, so the other thing we want to do is if we look at my Mario graphic, it's pointing right. If I'm going left, I don't want it to face right, I want it to face left. So what I'm going to do, after I've set the move direction, I'm going to say, let's set the effects. So that's effects, and you see a little blue box next to it, that's the one we want. Equals, and then it's sprite effects dot flip horizontally. So that'll flip it for us. Okay, right. That's everything we need to do for the left key. So I'm going to now set up the right key. So just below the brace, I'm just going to go if gm dot input manager dot key down keys dot right. You can use WASD if you want, but I hate that. And then we're going to say and not level dot hitwall center 2D. So the format is exactly the same. I'm just using different values. This time I'm going to use the right offset. Don't copy paste, because what you'll do is you'll use the wrong offset and none of it will work. So press enter, left brace, press enter again, put your code in. So this time move direction is going to be .x is going to be positive plus equals speed times GM dot event manager dot delta. So it's the event manager that keeps track of time values and things for us. Now, if we're moving right, we don't want any flip effects. So we need to make sure we say effects equals sprite effects dot none. That's the default, is none. Okay. Right, so that's left and right. Up and down, exactly the same process. So let's put some blank lines in under the if. And we're going to say if gm dot input manager dot key down keys dot up and not level dot hit wall center 2D up off left brace enter move direction. Oh, don't move down, move direction dot y minus equals, that's negative. Okay, speed times gm dot event manager dot delta. One thing that's peculiar with moving around up, down, left, right, if you go diagonal, you'll go faster. Okay, because of Pythagoras. And if anyone really cares about that, I can show you a way of refactoring. In fact, we can do it easily with the direction value. Okay, so if that is an issue for anyone, then I can show you quickly how you can do that. It's just a one-line job to fix that. But I'm not going to worry about that in this video. Right, moving up and down, we're not going to flip the sprite because I haven't got a graphic for moving up and down. Which is why you tend to do overhead graphics for these sort of games. It makes it damn sight easier. But if you've got animations for moving left, moving right, moving up, moving down, I can show you how to set that up. Animations are a little bit more complicated, not too much, just a little bit more. We're trying to avoid complicated animations. They're not really required, not for what we're doing. But if you get cracking on with this and you start want to expand it, make it a little bit nicer, I can show you how to do that. It does look nice when you've got animations like that. But I know some of you have got graphics that are just left-right graphics. So for up and down, we'll just leave it to whatever we were facing. Okay. Right, so that's the up key. It says prattling on. Let's just do the down key. So gm.input manager dot key down keys dot down, and as long as we're not hitting a wall, so level dot hit wall center 2D down off. Okay, enter brace enter move direction dot y plus equals speed times gm dot event manager dot delta. Okay. We could have done this loads and loads and loads of different ways, hundreds of different ways of doing this, but I'm just showing you this one way. If you need anything else, we can change it. I could have done it simpler, but it doesn't matter. Okay, right, so that is the key check. So just look, so I'll just zoom out a little bit. So we've got check for left, check for right, check for up, check for down. At the end, what we're going to do is we're just going to update our position. We're going to say position 2D plus equals whatever direction we've moved. Okay, and that is the last bit of code. He says theoretically we've got to write it. Okay, so that will take the direction information we've pressed with the keys and it will move the sprite in that direction. So let's just recap what we've done with the sprite. So in level, we have spawned the sprite from generate sprites. You can see it's here. We've given it an X position and a Y position. In fact, what I'm going to do is I'm going to change bottom and I'm going to just say pos.y so I get a center Y position. I'm just changing. You can change that if you want. In player, that's got now bottom, so I'm just going to change the parameter to Y. Now I've got an error now, but if I do control dot, it'll rename it for me. It's quite clever. Okay, so I've got an X and Y position and the level reference. So I store the level reference, make sure I add the sprite to the engine. define my frames, set up my animation. So every 5 pixels animate in reverse each time. Set up my start position. I've aligned my sprite in the center. Set up a callback to do my movement control. Set up a callback for broadcasting. Set up some offsets, which I built lists for up here. Okay, and speed and the move direction field. We wrote the move code. We just checked the keys and just made sure we weren't hitting a wall. And then if that was okay, we moved in that direction. And then we updated our position. Broadcasting our position for the view manager. And then the set offsets, we just worked out where we were going to check for collisions. Okay, and that is it. Right, so theoretically this should work. So if I run it, be a miracle. It didn't work. My other one didn't work. That was a cock up, but let's just see. So press 1 to start. There's my Mario. So I can move. Oh, didn't go through the wall. Ah, I think I've cocked up the up detection. I'm catching the walls. I've done something silly. Okay, but let's just check the scrolling's working. Oh, OBS is jerking me a bit. Crikey. Okay, so I'm moving along. You can see what's happened. My head's gone into the wall there. So I've actually got, and if I go down, if I go down, the down one's working. The left one's not working. The up one's into the wall. So I've got a direction problem there. The left one seems to be doing it as well. So I think I've just cocked something out. Right, right's okay. So up and left, the offsets are wrong. So let's have a look at the offsets. So the right was okay, but the left wasn't. It's probably something to do with the up. Done something silly there. Don't understand exactly. So let's try. Let's put -1 and +1. So let's just change the up. So you may have to play about with these so that your sprite works okay. That's even worse. Right, so let's do. No, it can't. Let's try taking a little bit off. Oh, why does this always happen to me? Let's set those back to what they were. The down one worked, so have I got left and right messed up a little bit? So we've got positive. Oh, let's just try it again, just so we can have a look at it. So the press 1, move down, left and right's working when we go down. If we go up, left and right don't work because we're in bed. You should stop there, not there. So left and right, the corner points, the heights need to come down on the top one. So that's a negative H1. So let's try +2 and do the same on the right. So that, the negative one is the one that's the top one. Let's try that. Aha. Okay, so that's now working. So it's still all right. I need to move the detection a pixel for the up offset. So where I've got HDiv, I probably need to subtract an extra 1. And this will depend on your graphics, how it looks. It doesn't matter if it overlaps. And another -1 there. So the Y part of the offset. Ah, there you go. His hat doesn't go in there now. So you'll have to play about it. If you've got any transparency around your sprite, so you can mess about with that. I could make it so half his body was overlaid. If you had like an isometric effect or a cavalier projection for your graphics, you could make it so you only check the bottom half of Mario or whatever character you've got. If you look at games like Bomberman, it does that sort of thing. So the up, touching an up surface, going left and right works. Down, That works. Right. So the one that was a bit dodgy was moving left and then we're stuck inside. So what that means is on the left-hand edge of the up and down offsets, we need to come in a pixel. So it needs to be up, off. So this is the left-hand one. So we need to just say +2. And we'll do the same for the down one, for the negative X part. Let's run that. Try that. So it's easiest to see it over here. So there you go. So my up and down's going. Let's just make sure the right hand side one's okay. That one looks okay. Okay, so you'll have to play about with that a little bit just to get an effect. And that looks okay. So there you go. I'm running around the maze. Unlike the people who do the platformer, you can actually get back out of this. So the only other thing to do is a little bit of collision detection, a bit of enemy AI, and a bit of shooting and stuff. Okay. You may need to do some spawners if you want like generators, like in games like Gauntlet, where you keep generating enemies. Oh, it's jerking again. But that's it. That's how you set up your collision detection for your player control character. And then that's how you tweak it as well, so you get it to work without sticking against the walls. Okay, I'll leave it there.